So this is a lesson on clean architecture and the repository pattern. In reality, after I finish putting the slides together, it's mostly clean architecture, but I tie back to the repository pattern at the end. So let me see. All right. Mainly one of the discussion, because there was a lot of confusion I see about the repository pattern. People are often implementing the repository pattern when they don't need it. They're kind of implementing the repository pattern in a stock way where they create a create, update, read, and delete method. And it's not clear why they're using that method to implement the repository pattern. People don't understand or want to know if entity framework replaces the need for repository pattern. So just a lot of questions around repository pattern. And without understanding what architecture pattern you're using, it can be hard to answer those questions. And so usually when I think about the repository pattern, I think about it in the context of the clean architecture or onion architecture, and it becomes a lot easier to answer all of those questions. Um, and mainly understanding what the domain layer is and what the infrastructure is and how those two are separated. And so the main things we want to avoid is just doing pointless busy work. So if you're creating a repository for every single table that you have in the database, that's rarely needed. Um, and if you're not using a repository pattern, not using any kind of separation here, you can end up with impossible to test applications. And those actually aren't exclusive either. So you could be making a lot of repositories and still end up with impossible to test applications. A repository doesn't really solve that problem. So going into the Onion architecture, the first thing you'll notice if you start looking into Onion architecture or clean architecture is that there are many different definitions when you look at the actual pictures and what the layers are. And that's actually okay. So just for an example, we look here, we can see there's several different versions. So we have domain model, domain services, application services, and then these things out here on the edge. This one we have domain entities, repository, service interface, infrastructure, and they don't even define what this outermost layer is. Um, Domain entities, repository, service interface, UI. These are all kind of boring. There's no interesting one here. Entities, use cases, interface adapters. This one's actually really popular, but it's again completely different. Frameworks and drivers. Um, Repository controller, domain entities, use case controller, or repository contract. So a lot of different, even a simpler one, core, and everything else. Actually, kind of like this one. But there's a lot of different ways that you can draw these layers, and turns out that the Onion architecture doesn't actually have any mandated set of layers. There's no rule that tells you how many layers you have, and there's no rule that tells you what those layers have to be. Um, there's only one rule for an Onion architecture, and that's that source code dependencies can only point inward. Nothing in an inner circle can know anything at all about something in an outer circle, which actually tells us nothing. That just says that basically you're going to define your application in layers. So your innermost layers won't know about your outer layers, and your outer layers are allowed to know about your inner layers. But it doesn't tell you what those layers can be. And actually, by itself, that rule is not terribly useful, but there's a lot of patterns that will start to emerge once you try and follow that rule. And there's also sometimes questions about where this fits. Does it replace MVC or MVVM? It doesn't. So your user interface here could be using MVC or MVVM. There's no rule. If you are using something like that, then everything here that's not yellow in this example would be really everything. Yeah, I guess everything that's not yellow would be the model from an MVVM perspective and also from model view controller perspective. So, um, and usually when you see this architecture referred to, it's about developing applications or an entire program. And if it's split up between back end and front end, it's usually just applied to kind of the back end. But really, the rule can define any kind of domain and what environment it lives in. And if you're building an application, you'll often have these outer layers as infrastructure controllers, things that connect to your database, things that connect to your GUI. But you could even have something like Newtonsoft JSON. It's a JSON library. It's not an application. At the end of the day, it's just a library that gets used by a couple different places. And they could follow the Onion architecture, and they kind of do, where their innermost layer is a tokenizing library that's really just interested in how do I take JSON and create a bunch of tokens out of it. So your JObject class, your JToken class, if you've used it before, these are the things that are really just a abstract syntax tree representation of the actual JSON string. Yet they have a whole nother layer that's built on top of that or around it, which is focused on data binding. So binding from tokens or JSON strings into actual objects. And that layer uses the layer inside of it, um, but the layer inside of it doesn't ever refer to it. So you could have an onion architecture without actually having, an application and these user interface and infrastructure layers. But then it's not, those applications typically aren't as complex, and so it's not as necessary to really think about it in this way. So it's mostly useful when you're designing an application. And so I really want to talk about kind of what your layers tend to be. So these two quotes I got from the site here. If you just look up clean architecture, this is the person that I found that's kind of written the most about it, Robert C. Martin. And so he has his dependency rule here, and then when he's talking about it, he brings in the second quote here, which is the further you go, the higher level the software becomes. The outer circles are mechanisms, the inner circles are policies. Um, so if you read that, that may not make a lot of sense. It turns out these two words, mechanism and policy, are very heavily loaded in the operating system development world and the kernel world. So there's this whole design philosophy about separating mechanism from policy. And so we can go jump into that. Mechanism is really how do I do something? It's the infrastructure, the boring stuff, your frameworks, they all fit in kind of the mechanism world. Where the policy is what do I want to do? And that's where your business logic and your domain logic goes in. So in the operating system world, um, you can think of this as for a file system, the mechanism is how am I actually writing files, copying the files to disk and things like that. And the idea of the philosophy in operating system design is your mechanism should be handled by the kernel and your policy should be handled in user space. So in user space, you would determine, oh, these are the files I want to modify. This is what I want to write, and this is what I want to save to the disk. Mechanism is all about how do those bytes actually get put onto the disk. How do those things happen here? And so in the operating system world, you usually have it almost the opposite way, which is your mechanism is your lowest layer, that's your kernel layer, and then your policy is on top of that, deciding what to do. In the clean architecture, it's the opposite actually. The outer circles are your mechanism, and the inner circles are your policies. And so it can be a little bit counterintuitive because a lot of times when you're writing policy, you want to use your mechanism. And so you can't do that directly because your mechanism is way out here. And so you have to get to it through some kind of inversion of control or different control model. But there's actually a number of different ways that you could look at an onion architecture and define the differences between the different layers. So in general, your outer layers are going to be more simple. Your outer layers, it tends to be very dealing with a lot of different things. Um, for example, if your outer layer is, infrastructure, then your outer layer is going to be dealing with a lot of different um, databases and schedulers, different application services. So there's a lot of things it needs to deal with. So you don't want it to do a lot, and you don't want it to be complex. Um, and then as you get more into the inner layer, then your code can get very complex. And this actually works well because your outer layer tends to be harder to test, whereas your inner layer should be a lot easier to test. If you want to test the stuff at your outer layer, you often have to set up a full integration end-to-end test with all of the various components that you need. And so if your code in the outer layer is simple, you don't have to write as many tests. And then the code on the inner layers can be very complex. And that's where you can write a lot of really interesting tests and just a lot of different test cases to tease out all that complex behavior. Inner layers tend to be more reusable than the outer layers. Um, this is just onions tend to be more bitter as you go inside. Application focused, and domain focused, those two are kind of opposites. As you go further out, your code is more thinking about how do I get this application to run. So if you think your application was something like, I've got a couple of different examples of applications, but for one, let's say you're building a web service where it generates memes. So you can take an API request which tells you what image you want to make a meme for, and you can give it some parameters for, what to put text to put in the various caption pieces of the meme, things like that. So your outer layers are going to be thinking, I am building a web application that generates memes. So they're going to be application focused. They're going to be, how do I implement that application? Whereas your inner layers are going to be domain focused. You might have an inner layer that is, an image manipulation library. How do I, and its entire domain is how do I manipulate the pixels of various images to put text in certain places? You might have another piece in your inner layer, which is kind of the idea of a standard memes collection. So it knows about, okay, what are all the memes that I have available to modify? And for each one, what are the various pieces that I can modify? What are the various places where I can put captions and things like that? And so that maybe is its entire domain. So those pieces aren't aware that they're running in a web application. They could be just as easily running in a command line application, a desktop application. Um, they could just be a library that gets reused by other applications. So they're not really aware of the idea that they're running an application. This tends to make them more reusable, and it makes them less application focused, more domain focused. As you get further out, this is just the opposite of reusable. It becomes more single purpose. So your infrastructure, that's connecting to the database, um, your API, those things aren't going to be shared by other projects very often. And then again, if it's harder to test as you go further out, typically you have a lot more tests as you go further in. So let's take a look at some various things and try and figure out whether they are inner or outer layers in an onion architecture. And there's no hard and fast rule. Something that's an outer layer for one application could be an inner layer for another application. So let's just go through these. A method that uses Postgres's copy to command to achieve superior insert performance for bulk inserts. Um, I realize I'm using some words here that sound like I'm selling Postgres, but this is actually just a problem I had to solve recently, so it's on top of my head. If you're going to be tied that closely to your database, this is going to be something that's in a layer pretty far out. This is very much mechanism. Um, this is very much um, tied to a particular database. This is not going to be terribly reusable. This is something that's going to be in a layer that's pretty far out. And actually, this is something that you would often find in some kind of repository implementation, or if you don't have a repository, just in your data layer, which tends to be on the farthest outside of the onion. Controller translates HTTP requests into method calls, which really is just the definition of a controller in ASP.NET MVC stuff. But basically, your controller is typically also pretty far out in your layers. It's going to be one of your outermost layers. And the idea is that, again, this is really just infrastructure. This is where your API gets defined. This is it could be very specific to your application. It's not something that's going to be inside. Now, the wording here could be a little bit vague. If you were writing a framework like ASP.NET MVC, then this controller concept would be something that's very core in your domain and inside of one of your most innermost layers, writing the base controller class. If you're using that framework, then your controller implementations are going to be something that's in your outer layer. So some of these questions can be kind of hard to answer without knowing exactly what your application is. A use case command that takes in a scheduling request, fetches a course, and checks to see if it has any free space, and if it does, assigns the student to a course. So this is going to be not your farthest out layer. Now we're actually starting to talk about the domain and the application world. So this is going to be something that's maybe a middle layer. It's not terribly generic. It could be your innermost layer if you don't have a lot of layers, but this is going to be further in than your outermost layer probably. Image processing function that performs a Gaussian blur on an image. This is usually going to be an inner layer. This doesn't have a lot to do with the infrastructure of your application. It's not your API. It's not kind of how things are coming in or going out. This is really a business logic type module that you would probably find inside your layers. Scheduler schedules jobs at regular intervals. So this is one that often people can think of as something that's in an innermost layer. This is actually another piece of infrastructure that's very often in your outermost layers. As you have your application, one thing that tends to be in a lot of your outermost layers, and I didn't add an example here, is the various events that drive your application. So if you're building a web application, API requests are one of the big events that are going to drive your application. And then the scheduling is often another big event that's going to drive your application, which is, maybe every 30 minutes you do some kind of database cleanup task. So the database cleanup task is going to be in here somewhere, but the scheduler that starts and stops that, it's just kind of like your controller switch. It's way on the outside, and it starts all your requests. All your requests tend to start, and by requests, that's not the right word, all your actions, everything that kind of happens in your application is driven through one of our workflows. And those actions all tend to start on the outside and work their way in. So your scheduler tends to be way out here. Another thing that's in this line is your main method. So your main method is often one of your most outermost layers, if not the outermost layer, and it's going to be taking in, command line arguments, um, returning an exit code. Those are pieces of infrastructure, and your main method should translate all of that into calls against your domain, and then it's going to return it and translate it back as an exit code. And that can be, if you're writing just a command line application, you can still follow this architecture. Your main method is on the outside here, and then you have layers on the inside. A socket listener that receives packets and runs tasks to process the commands. So this is similar to a controller basically that's taking in HTTP requests. This is going to be something that's on one of your outermost layers. It's going to be starting actions and workflows and driving them inwards and then returning the responses outwards. All right, what is the center of the onion? Which for the slide and the next slides, I tend to refer to as the domain. And center is a very vague word. If you have this onion here with a couple of different layers, when I say center, am I talking about the innermost layer or this layer here? I'm talking about the layers that tend to be on the middle. There's no, when I talk about the domain, I might be talking about the bottom 2 or 3 layers in this example. I would really call this entire thing from the teal cyan on in the domain, and this outer layer would be really your infrastructure. All right, so what goes inside? Well, sometimes nothing. Um, so if your application is just connecting a database to an API, which is how a lot of applications start, there is no domain. If you have a DB context and you have a bunch of controllers and those controllers call into that context directly, or even if they call into just some services, but those services don't really have any cohesion or purpose to them other than I know my controller is not supposed to call my context because I'm following some certain rules, so I put it in a service. Uh, you may not have a domain. And so one way that you can kind of think about it is, well, if my database had an HTTP interface, how would it be different than my application? Um, so, you can think the Entity Framework demo application I've seen where they kind of have students and teachers, I think, and just a couple different entities. And their entire application is just a bunch of various translating API calls into calls against that database. There's no domain there, um, just because, and even there, uh, they kind of have one class, one call per database table. You could say, someone could maybe argue that, well, defining the entities themselves is kind of your domain, the student and the teacher. But if your entities are defined based on your database tables, where you have one entity per database table, it's not really much of a domain. Really, you're just exposing your database at that point. So then, once your application gets more complex, it's going to be doing more than just exposing the database. Um, and those bits, everything else, is probably your domain. And that's for your basic web application. So as I was mentioning, if you have an intelligent main method, or you have a socket connection, or you have a scheduling connection, you may have other pieces of infrastructure that aren't your domain. But your domain is basically the stuff that's more interesting. So a couple examples here. Use cases is a pattern that is slightly above no domain. And that's the idea of, okay, I'm not just exposing the database because I'm allowing for updates, and those updates happen in kind of interesting and particular ways. So if you take uh, that student example, and let's imagine we're building a course scheduling system for the university, um, then you're not going to be, you'll have this layer that has to know things like one of the methods might be, okay, I take in a scheduling request from a student. I have to look up the course that they're trying to add. I have to make sure that the course has space for the student. I have to make sure that the student is qualified to take that course. I have to make sure that the student is not already taking too many courses. Figure all of those things out and then make the appropriate changes to the database. And so there, when I say use cases, sometimes you would write that application by creating use case classes. And one use case would be, satisfy scheduling request. And it would go through and do those various changes to the database in a unit of work or a transaction. And now you have a little bit of domain. That use cases layer would be inside there. If you're building a DNS server or a DHCP server, then you're going to be taking in requests over a TCP socket. DHCP might not be TCP, I don't know off the top of my head, but you're going to be taking in requests through some kind of socket, and then you're going to have to do logic. So for DNS server, it's going to be looking up the name, looking up the records that they're asking for. There's a little bit of recursive logic. So if I can't find the record in my local database, then who do I know to go look for to find the record next? So I have to ask for the parent domain or something like that. Um, and so that little bit of logic that would be in there would be inner layer. Both these examples would be very heavily infrastructure, small domain. DHCP, there your domain is going to be, okay, I have a list that I'm allowed to assign. I need to pick the next address out of the list. I need to keep track of how long it's being used. Free it up when I don't get a request in so often. And so there's a little bit of logic on the inside there that's going to be the domain. And then there's a lot of kind of socket infrastructure on the outside. If you're building an online game, you're going to have a massive domain that can probably have layers and layers of its own. And you're going to have a ton of infrastructure. Your online game may have a database that it uses to keep track of user scores or something like that. Um, Infrastructure for various timers that are going to be, canceling your game or something like that. You could have even multiple layers of infrastructure. So that one is pretty easy to see. That one's complex. The whole game itself is going to be your domain, and then just how that game connects to the various infrastructure pieces uh, will be your infrastructure. An online store checkout system. So again, this is going to be kind of similar to the use cases example, where you might have like a checkout use case, which is doing a few things to the database, but it's also making calls against remote APIs to try and figure out if the purchase can be made. So, making calls against PayPal or credit card processing APIs to make sure the purchase can be made. Making calls against USPS to do address validation, all those kinds of things. And there's going to be inside the domain, not necessarily in a database, but probably in some kind of in-memory storage, shopping carts per customer and keeping track of those shopping carts. So we talked about this, and now we can kind of look at starting here can be difficult. Uh, when you're starting your application, you shouldn't sit down and draw out all of the layers that your application is going to consist of. Now, if you've written a bunch of web requests and you have, it's not web requests, but web applications, and you have a good sense for, oh, I know what my inner layers I want them to look like, you might have some patterns or things that you start with or follow, and that's okay. But assuming you don't, or you're writing something new that you haven't really written before, it's not a good idea to sit down and draw out all of the layers of the application that you're going to need. Um, you should start with one layer. It's not even an onion at that point. It's really just a ball. Or you could even start with, that's what I was saying, kind of like this picture. Um, this is what I often start with a lot of times, which is just, okay, I know I'm going to have controllers and a GUI, and those are going to be separate layers. I know I need to kind of set that all up in some kind of outermost main method and get it running. I've got a web server. I know a few of my outer pieces, but I don't know anything about my domain yet, really. Um, the everything is agile these days. You're not really supposed to sit down and fully design your application. Really, just hit the ground running. Just start writing code and don't worry about it so much. Let everything be one layer. So, if I were starting an application, and this is kind of where I'll start referring back to the repository pattern, creating a repository is one of the last, I mean, it's not something I would do at the start of an application. Um, because if we're just starting with one layer, or um, even this kind of layer here, don't really need it. But let's assume we're just starting with one layer, one giant kind of outer ring. You can just call directly from each layer to each other layer. You don't have to create interfaces like repositories to escape things out. Just start simple, start writing some interesting applications, and then don't bother actually creating layers until things start to get cumbersome. And they will pretty quickly if it's just one layer. Maybe not that quickly, but maybe you've written 10 or 15 different API requests, and now you have enough code, you can actually start to look at it and say, okay, really, what am I doing? What do I have that's kind of in common here? And you can start to pull out pieces of your domain. So maybe if you're writing a scheduling application, to start with, just go ahead and let your controller call directly into your DB context and start satisfying some of those scheduling requests. And then after you've written, 5 or 6 different methods, you've got a little bit of your application going. Then you can look in and you can say, okay, what really is my domain here? Am I following this sort of use case pattern? Do I have a different pattern? Can I extract an inner layer that's all about scheduling and figuring out which courses students can take? I can imagine in that application you may end up having an inner layer, which is really its whole purpose is to figure out whether or not a student is qualified to take a course, and that can become its own domain entirely. And so then you refactor and you push those things into inner layers at that point. So yeah, definitely when you're building an application, you're going to be more effective if you don't sit up front and design all your layers, but you do have to often and regularly expect to do some massive refactoring of your application and push those layers inwards. And I realize I'm not, oh yeah, so ton of refactoring, your application will give birth to this new layer, and then you just keep going through. You keep writing that, and then at some point, some other layer is going to start to bulge. Maybe again, it's your outer layers are starting to get too large. This is getting too confusing or too complicated or too hard to test. So then you go and you pull out another layer. Maybe one of your inner layers, that scheduling thing, could even get very complicated for some reason. Maybe have very precise rules around scheduling. So you need to pull out yet another layer, which is about, and when we're pulling layers out in the domain, they're not always um, inner layers. We could be splitting our domain like we split our outer layer into just multiple parallel layers. So you could have, a scheduling layer which figures out can a student take a course, and then you could have another layer here which is figuring out, which courses can professors teach, and that's not a great distinction, but the idea is you may have a lot of different pieces in your domain model that aren't necessarily 10 different layers, but you may have kind of 10 different bubbles in your domain model that are all somewhat self-encapsulated. Um, yeah, and so then I mean, if you're going to actually write an application with clean architecture, it's not about picking the best set of layers. It's not about defining all your layers up front. It's about writing code until it gets hard and then creating a new layer on the inside. And that being said, there's no harm in, if you're following a few set patterns or something like that, there's no harm in having a few predefined layers at the start of your application. But typically your domain, when you're starting, I see this a lot, and that's okay. But having this split into multiple layers is pretty rare at the start. Now, if you're working for a business and you've written, you're writing some kind of microservices architecture, and so there's already 9 web services that have already been written, and you're writing the 10th one, then you may have some set of standard inner layers or something like that. But when you're getting started, don't worry so much about it. Um, just write code and then refactor into layers as you go. And you just really need to be aware of how the layers work so that you can do that refactoring. All right, so I promised I would talk a little bit more about the repository pattern. So if you look at the definition of the repository pattern, it mediates between the domain and data mapping layers using a collection-like interface for accessing domain objects. Now, this was written a long time ago, so um, the wording still kind of applies. But the important thing I think here that a lot of people fail to realize is that the repository is defined inside one of your inner layers, and it describes how one of your outer layers should behave. Um, so your repository lives, the interface definition lives in your inner layers, and the implementation lives in one of your outermost layers. A lot of times, and so your repository, for example, shouldn't be based on how many tables you have or how many classes you have in a DB context. So like if you create a DB context and you have 3 entities in that DB context, and so then you create a request, a create, read, update, delete repository for each of those entities, that's just wrong. Um, your repository is not supposed to be written with your database in mind. Your repository is supposed to be written with your domain in mind. And a lot of times, um, let's talk about what that would mean. So if you don't have a domain, kind of as I was starting here, which is at the beginning, it's just really one layer. You don't need a repository because you don't have anything that you can define that repository for. Um, and then if your domain isn't really aware of persistence, you don't need a repository. So if we jump back to that scheduling application for a minute, let's say you've written your 5 or 6 requests, and now you create a layer on the inside. And this layer is just doing all of that complex logic to figure out if a student is qualified to take a particular course. Um, that logic doesn't really have to be necessary of the concept of a persistent database. If I was writing, let's give that thing a name. If we were writing at oh, naming is the hardest thing, but the course calculator library, which is a terrible name, but we'll live with it for now. You could just have a method in that library, which is can student take course, takes in a student and a course, and it goes and it figures that out. Now, it may need some information to do that. It may need to know, okay, what are the other courses the student is taking? Um, what are the other courses, classes that are available? I need to know about the various um, curriculum or requirements for various majors and things like that. So it may need a lot of information, which will eventually come from the database, but it's not going to be coming in a standard repository create, read, update, delete. For example, that particular domain piece is not going to be doing any updates or deletes. And so a repository for that class would really just be, hey, how do I get the list of all the classes that are available? How do I get the list of all the classes that a student is taking? Um, so the interface should really be written with that domain in mind. So your interface, your student interface might only have one method, which is get courses for student. And that's your, that could be your course repository or something like that. And then you don't need all of those other methods. So, you know, first of all, if you don't need the repository, don't create it. If you do, you got to have to create it with the domain in mind. Another example that we had back here is I was using a while ago, the um, meme making application where it has this database of memes and how they can be modified, and it takes a request, which is, I want the, um, you know, thinking person meme, and I want this caption to be on there. So the actual, you might have a domain, which is all about how do I put those captions onto the images based on these definitions, which tell me where those captions are supposed to go. And it's doing all this image manipulation, maybe even image loading and image modification, and then returning an image. That domain piece, again, doesn't really need to know about the concept of database. It will need a meme repository. So given a meme ID or meme name, go give me the meme definition for it. But that repository exists entirely of one method, which is go get the meme for this definition. And even then, you could just grab it in your controller, your services layer, your outermost layers, and then pass it in. So your meme domain could have a method which is, create meme, takes in that image definition, and maybe one piece of that is the file location or something like that, and a list of captions. And so then it doesn't need to go query for any information. It has all the information it needs. It can just go do what it needs to do, and it can return it. And so you could build that entire application without ever having a repository. You would still have a database. All those meme definitions would be stored in the database, but you would pull it out of the database in one of these outer layers and pass it into your domain directly instead of your domain asking for it through some kind of repository. Um, and this, of course, means that you could have multiple repository interfaces in a single application. So again, if you're creating a DB context and you say, I have 3 models here, so I need to go create 3 repositories, um, that's not how they get created. You could have 4 or 5 different domain pieces because maybe your application does a lot of different things. And each of those domain pieces could have its own definition of what a repository should be. And so you'd have, you could have a database with one model and you could have 4 repositories, 4 repository interfaces, maybe only one implementation, depending on, what kind of application you're building. So um, just to close off, there are a few other things when looking at repository that kind of go over this. one second. Right. So if I'm looking at Microsoft, um, you Google their Entity Framework stuff. Just Google for repository pattern. This is one of the things that comes up is from the .NET Microservices Architecture ebook. And actually, this is basically saying that your DB context is your repository. Um, and they have some interesting points here, which is, again, there's a repository per aggregate root. For each aggregate root, you should create one repository class in our Microservice based on domain-driven design patterns. I'm not it's kind of comes down to the way they define repository, but basically they're saying the repository is the DB context itself. So you could have multiple DB contexts, and each of those has a DB set, and your DB context is your repository. Um, so that's the way they kind of define repository, which is fine. It's different than the official definition, which is mapping between the domain, although not really. So they see the domain as the entire application in this case. And so they're just saying the repository is a way to abstract out the database. Um, and so if that's how you see repository, so that's an interesting point, so I'll follow up on a second. They're basically saying um, the database itself is yet another layer on the outside of all this infrastructure. So their infrastructure is built in two layers. So controller request comes in, and it goes to the repository, which makes the request against the actual database. And so in that case, your domain is still your application. It's very much aware that you're connecting to a database so that you can provide domain services. You don't need to abstract out the idea that you're connecting to a database. You don't need to make a repository that's create, read, update, delete. Your repository in that case is the DB context and the DB set classes provided by Entity Framework. And just that's where you could have kind of the idea of maybe switching out a database or something like that and using DB context and DB set. But if you define a repository that way, then sure, you'll always need a repository, but you should never be creating that repository interface yourself. It's just the thing you get from Entity Framework, um, which being that they're making Entity Framework is a reasonable way to define that. And even then, they still have this quote at the bottom here, which is repository shouldn't be mandatory. Um, so Jimmy Bogard, I don't know, he's done things. I don't really know who he is, but said, this will probably be my biggest feedback. Not really a fan of repositories because they hide the important details of the underlying persistence mechanism. Um, and so it goes for the mediator for commands. So this is a bit of an interesting point. Use full power persistence and push all that domain behavior into my aggregate roots. Usually don't want to mock my repositories. So the idea there was a sound. I'm not familiar with what that sound means, but maybe I got cut off and that's the end of my recording. I don't know. It's an interesting idea here when it's one thing where even repository frameworks like Entity Framework can fall down when you're trying to do very specific things for performance with your database and you need to just do raw SQL or something like that. And so then, if you want that full power, even the repository pattern doesn't work all that well. The mediator pattern is an interesting way to go about that. That's probably a whole nother presentation is mediator pattern, CQRS, and what all that might mean. The point here is that he's saying, oh, you don't necessarily need a repository. Shoot, this is kind of an anticlimactic ending, but that gets to the end of what I was trying to go through, which is if you're going to talk about a repository pattern, you need to have a bigger architecture model in mind. And if you're using the onion or the clean architecture model, then before you even start really thinking about repository, you have to have a much better understanding of what your inner layers are. And so people sometimes ask why I'm always saying you don't need a repository. And it's because if you're just starting up, you don't really have enough of a definition of your inner layers to define a repository. You don't really know what your domain is. Um, and just a lot of the repositories that get implemented are kind of pointless and not really serving any purpose. So feel free to explain in future feedback all of the reasons you think this is a terrible idea and that you should always create a repository, or give me any questions or anything you would be interested in learning about more in the future. Thanks.